everyone, welcome to the lecture 12 of course Climate Change and Extreme Events. In the previous lecture we have talked about different types of probability distribution functions. Then we have also talked about why we should use these different types of probability distribution functions in climate data set. Then we have also touched upon what would be the relevant information we will get when we will utilize, let's say, normal distribution or log normal distribution or extreme value distributions like that, and why it is very important to understand the probability and magnitude at the same time to quantify the effect of, let's say, whether the climate is changing and what would be the magnitude of that change, whether the extreme events are becoming more frequent or what would be the magnitude of these extreme events like that. In the previous lecture we have also talked about multiple extreme value distributions, and then we have also talked about, let's say, why we call these processes as extremes, because they are occurring in the nature in very rare scenarios with the magnitude of these events are very high, let's say in case of maximum temperature or let's say floods or let's say some other different extreme maximum events. But in some other scenarios, for example, if you talk about drought or minimum temperature or low rainfall like that or low flows like that, we are essentially look at the processes or the data set which gives us the lowest or low magnitude event as well. So, in these different types of events or processes, we are essentially looking at the probabilities and their magnitudes and how frequent these events are occurring in the nature in different parts of the world, so that we can say, okay, the previous climatic scenarios or let's say historical period since 1980 to let's say 2000 or something like that, we have a little less amount of extreme events. However, because of the change in the climate conditions, anthropogenic activities and all that, these events are becoming more frequent in different parts of the world. So, that is basically gives us a tools, that is gives us a technique to understand how we can quantify different types of extreme events and their magnitude and frequencies. We have also discussed several types of softwares. We have also talked about several types of libraries and packages and all that can be used in different programming languages, or you can also use different types of softwares which is SAS or some different softwares like that can be used directly to fit the probability density functions or distribution functions and can get the relevant information from the climate data set. So, these are the information we have already covered in the lecture 10 and lecture 11. In this particular lecture, we will talk about how we can analyze the frequency and intensity of extreme events, what are their tools, methods for let's say understanding of climate extremes, so that we can have a some sort of meaningful information of some certain place, different parts of the world. So, in this particular lecture, we will primarily discuss about understanding and the importance of analyzing frequency and intensity of extreme events. We will also explore some of the statistical methods for extreme event analysis, although we have covered some of them in lecture 11, but we will touch upon some more advanced technique in this lecture as well. Then we will also evaluate or apply some sort of metrics which can evaluate the trends and frequency and intensity in the data set. Then we will also see one or two examples where these types of analysis can be applied and can give us some more meaningful information to climate science or let's say policy mitigation or some sort of policy formulation in different parts of the world or specific regions like that. So, as we have discussed previously also, why analyze extreme events, why it is important. Extreme events, if you talk about floods, droughts, heat waves, storms, these events are occurring in the nature very less frequently However, their magnitudes are so high that it can affect the societies, it can affect the economies, it can affect the biodiversities, ecosystems across the world. Therefore, analyzing these extreme events are very crucial in order to formulate some sort of mitigation policies, some sort of adaptation measures, mitigation steps. We need to know about how these extreme events have been evolved in the past few decades. So, therefore, what is the important property of extreme events? We have to find out what is the frequency of extreme events, what is the intensity of these extreme events, and what would be the potential impact caused by these different extreme events across different parts of the world. That will basically give us a more insight about preparedness and decision making, because if we do not have the information about, let us say, how frequent floods are occurring, or how frequent what would be the magnitude of different flood intensities, or magnitudes like that, we can plan some sort of preparedness measures across a river channel or urban areas or some sort of agricultural fields like that, so that we can minimize the negative consequences of these extreme events like that. So, when we basically try to analyze these extreme events analysis in climate science, there are two questions which are very prominent. First is how often these extreme events are occur in the nature, and what is their intensities, whether a very high intensity event are occurring less frequent, or very high intensity events are occurring more frequently in a certain part of the world. So, when we quantify these different parameters, this gives us some certain degree of the risk quantification, so that we can quantify the risk of occurrence of these extreme events across different part of the world. These risks are based on their estimated probability of occurrences and with their magnitude, plus the disaster preparedness in those areas like that. How well we are prepared for, let us say, 100-year floods, or how well we are prepared for a very long duration drought condition in certain part. So, that is basically when we have probability assessment, we can assess the risk of different infrastructure, agricultural areas, public safeties like that. When we are talking about, let us say, disaster preparedness, we are talking about essentially the climate adaptation strategies, how to mitigate the or how to overcome the negative impact of these extreme events in the longer run. Urban planning, how do we plan those cities or the people who are residing near the river channels can be less affected because of these floodings, frequent flooding problems, and how do we our emergency response, suppose a catastrophic events will occur, let's say tropical cyclone, or let's say earthquake, or let's say some sort of very extreme events occurs, what would be our the emergency response like that. So, the application of extreme events gives us a more understanding about the flood risk mapping. It gives us a better understanding about heat waves analysis. It gives a more sense about how we can manage the drought, and how we basically can manage the infrastructure design, so that we can mitigate it for future conditions. So, this is the importance of analyzing the extreme events. So, how do we analyze these extreme events? We collect the data. The data can be originated from either the meteorological data, observed data record, or some sort of automatic weather stations, or let us say point data collection points, where we are measuring simply the rainfall like that. These are the historical records, suppose we have, or maybe we can look at some sort of remote sensing data set. Suppose there are several different satellites which also measures or calculate the different meteorological properties, like let us say TRMM data. TRMM is a satellite which can measure the rainfall, and that can be used for our remote sensing data set for extreme value analysis or extreme climate change analysis like that. Once we have get the data from different sources or one sources, we basically organize the data into some sort of time series format. Then we try to find out the event identification. So, the first criteria is to define the extreme events or categorize these events into different categories. In the previous lecture, we talked about how do we define the extreme events. It is basically based on either the peak over threshold method, or it is based on block maxima or annual maximum method. So, based on those method, we basically can calculate different types of extreme events. We will categorize those events which are extreme in nature, which is not less extreme in nature, like that, and then we will use those extreme events in some sort of statistical analysis. What is the statistical analysis? These statistical analysis are identification of the probability distribution function. Then we can do that some sort of parameter estimation using, let us say, maximum likelihood or Bayesian method. Using these multiple methods, we can find out the parameter of the probability distribution function. Once we have the probability distribution function, which means the specific type of probability distribution function for a particular data set, we can calculate the return periods, the probabilities, and their accordingly the magnitude. Once we have all this, we can also do some sort of more analysis. Let us say we can work on the trend analysis, we can work on the stationarity or non-stationarity analysis in the data set itself, so that we can pinpoint whether is there any trend in the data, or is there any breakpoint in the data, or is there any significant change in the statistical properties which has been occurred in the data record. So, these are the data analysis we can do using all these data set. Once we have the meaningful information out of these statistical analysis, we can quantify the risk. Risk is basically a factor of one is the probability of occurrence, second is the magnitude, and third is your potential impacts. It could be, let us say, people who are very economically not very good in conditions. So, they are living very close to the river channel, and therefore, if a very high impact flood will occur, they are going to be highly vulnerable there. So, therefore, we have to identify those region or those economical classes or something like that, so that we can understand the risk of any extreme events in different parts of the world. Once we have identified the risk, we can plan the scenarios. Suppose in different scenarios in the future condition, if the global warming is like that, is 2 degree, 4 degree, 1.5 degree, like that, what would be the future of a certain region, how the floods will occur in that particular region, and how frequent, and what would be the impact of different strata of economy, or different, let us say, economical or socio-ecological or ecological conditions there. So, we will identify the high risk area and population based on the scenario planning, and then we will do some sort of decision making, and then we implement and monitoring those data set there. So, the frequency and intensity is one of the most important parameter when we are dealing with our extreme analysis. So, frequency generally refers to the number of extreme events occurring over a specified period of time. It captures how often such event take place is crucial, which is understanding for trends and pattern in the extreme event occurrence. So, frequency generally you can define as the how many times a particular event has been occurred in, let us say, past 10 years, past 1 years, or past 5 years, depending upon what would be your application of the temporal resolutions. So, it could be applied in the heat waves, it could be applied in the extreme rainfall condition, drought frequencies, or maybe some other extremes like floods, forest fire, or tropical cyclones, like that. On the other hand, if you talk about intensity, intensity refers to the magnitude or severity of individual extreme event. It generally provides information about what would be the magnitude of a particular event, whether it is too strong or very extreme condition or very low conditions, like that particular event. So, for example, we talk about maximum daily rainfall, then we captures the most rainfall record in the daily day, and then we compare what is the magnitude of, let us say, 2001 maximum daily rainfall, what about 2010, what about 2005, like that. So, that how basically we compare the intensities of different rainfall event. Then we talk about highest river discharge. Similarly, like rainfall, we also calculate what would be the maximum river discharge for different period, or let us say 1 day or 1 month or 1 year, like that, and then we can also compare. Similarly, we can do maximum daily temperature data, and then we can identify what is the highest temperature record, and similarly we can also do for peak wind analysis, like that. When we talk about frequencies, we basically are essentially looking at their increasing or decreasing pattern, what is their climate change impact, and then we can also talk about, let us say, if we know the frequencies, we can talk about what is the flood frequencies, what is their event and estimations, and then based on these information we can talk about disaster preparedness, urban infrastructure planning, and overall understanding of the climate event frequencies based on the data set. So, what is the significance in this analysis? Because we can, based on these two different properties, we can quantify the severity. Based on that, we can design the standards, infrastructure and all, and we can also talk about understanding risk. High intensity events can lead to, for example, catastrophic damages across world. So, we can quantify the risk as well. So, there are statistical tools for this kind of analysis. One is called the time series analysis, where we try to look at the trends in the data. So, suppose we have applied the annual maximum series or peak over threshold method, we identified the maximum event or extreme rainfall or extreme precipitation or extreme temperature events, and based on those records we basically try to identify what is the nature of time series data set, whether there is a long term trend, whether there is a no trend at all, or whether it is a decreasing or increasing trend, like that. Based on that, we can identify the frequency of heat waves or different extreme events. We can reveal the trends, seasonality, how frequent they are coming, or what would be the seasonal behavior of these different data set, and that can be used for non-stationary analysis and all, like that. The challenges of these types of analysis is basically to when we have some sort of data gaps or that require some sort of pre-processing for detrending or those data set, that is sometimes can pose some challenge in the time series analysis. Then another tool is called extreme value theory, which we have already discussed in the last class, that basically model the statistical behavior of rare and high impact events, and using these extreme value theory we can use GEV distribution or GPD distribution. Based on that distribution we can identify what is the flood magnitude, flood return level, and then we can model the extreme heat wave or wind speeds or those types of analysis. What are their strengths in the extreme value theory models? That can focus on tail behavior or extreme in behavior, and then also can be suitable for, let us say, quantification of those rare event probability estimations, like that. Sometimes there is a challenges of these types of theory is basically to choice of the threshold or block size, or let us say sometimes there is a problem with the parameter estimation of these models. Not it's very not very common challenges, but sometimes it may occur. Then there is another tool is called Poisson regression, which is used to quantify the or analyze the event counts and their relationship between frequencies and covariates. So, these kind of regression are used to model the number of extreme rainfall events per year or examine the links between climate drivers and their event frequencies. So, when you apply this Poisson regressions, we can handle the frequency of occurrence of extreme events, and we can count the data effectively, or we can project it for different time period or in the near term conditions like that, or maybe for different scenarios as well. And then we can also incorporate the ancillary informations, for example, some sort of explanatory variables, temperature, seasonality, ENSO like that, to quantify how frequent different types of events are occurring in different parts of the of words like that. This model assumes the independence between events, therefore, we have to be very careful about when we are applying these model. We have to be very careful whether the events are interdependent or not interdependent like that. We have to check that. Or over dispersion in data may require adjustment. Sometimes if we have very less frequent or over dispersion data in the data set, we can try to minimize that error in the data. That is sometimes pose challenge when we are applying some sort of Poisson regressions. Then we are also have discussed about threshold analysis, which is also very important, where we try to find out what is the threshold above which a certain time series or data points can be considered as extreme events. It is generally used for floodings or wind gust or some sort of different weather related phenomena. It is very simple, but it is used in your EVT or peak over threshold or GPT distributions like that. And there has to be we have to be very careful about selection of threshold. So, we have also discussed in the last class. There is a MRL method, which is basically we can use to quantify what would be our perfect threshold for different processes. Then it will also give us information about the threshold and their relationship with the extreme events. So, we know that the global temperature is rising, and therefore, because of the global temperature rising, lots of extreme events, particularly let us say extreme temperature events or let us say heat wave events or drought events or flood events like that are increasing in the nature, and therefore, it has to be a model separately. For example, we have to talk about what is their frequencies or occurrences. So, one of the best way is to use the Poisson regression model, where we can model the probability of occurrences with their number of events. So, in the y axis we are plotting different probability densities or probability of occurrences. In the x axis we are plotting the number of events in the certain locations. So, if you look at, there are different types of Poisson regressions we have compared. Lambda is equal to 1, lambda is equal to 4 and lambda is equal to 10. So, when we are talking about, let us say Poisson regression lambda is equal to 1, here it gives you an idea about the events which has less in number or occurring more in frequently in certain region. However, when you increase the lambda is equal to 4, it basically suggests that the events in the medium range of occurrences, number of occurrences has more frequently occurring in the nature compared to the lambda is equal to 1, where the low number of events are more frequent. Or let us say if you increase the lambda is equal to 10, then it basically suggests that number of events are higher in the probability, and therefore, this is a condition where more number of events are occurring in a certain settings like that. So, in a way, this types of regression can be modeled, can be applied in a time series data to get an idea about whether the climate change has changed the frequency of occurrence of extreme events in different parts of the world or not. So, maybe if you have the data, let us say temperature or rainfall or some other weather properties, you can divide the data into two parts, let us say 1970 to 2000 and 2001 to let us say 2024, and then you can compare the data whether any frequency of change has been changed across these parts of the world, or is it remained same. What is the lambda value? That can give you a very good idea about what is their frequencies. This is another example where we are applying the extreme value theory, where we have identified the annual maximum daily precipitation record and we have quantified the densities. So, here we are quantifying what is the probability, the frequency of occurrences plus their magnitudes. So, the intensity and the probability we have compared, we have made up some sort of mathematical expressions that is basically based on extreme value theory, and then we can compare what is their occurrence in the probability and what is their likelihood magnitude. So, we can quantify these identify these types of extreme events or precipitation extremes based on certain thresholds, where we identify these different data points which we have already discussed in the last class. Then there is another further matrices to understand the quantify extreme events. Researchers use various statistical matrices. These matrices helps us extreme events, how severe they are and how they have evolved over time. For example, we talk about a recurrence interval, where we measure the average time between events of a specific magnitude in EVT, extreme value theory. Or we can also talk about what is their event count per year, how many times a particular event has been occurred in a particular year. So, these are some sort of frequency metrics. Then we can also identify the intensity metrics, where we talk about certainly the peak values, what is the magnitude, or what is the integrated matrices, where we compared frequencies with magnitude and then make some sort of integrated matrix like that. In the peak values, we compared what is the highest observed value, or in the integrated we compare or evaluate total impact on a certain regions like that. What is the combined matrix? Combined matrix, where we are using the frequencies plus the intensities and their durations. So, this is frequency, intensity, duration, that is the relationship when we use for different types of extreme events to quantify the combined extreme event analysis for a certain part of the world for different extreme events or climate change conditions. So, these are the some examples of rainfall intensity with duration and their frequencies. So, you can see if you increase the duration or frequencies of the rainfall, we have very different types of intensity and frequencies results. So, that is basically can be compared, and then we can have a meaningful information about how we can compare the rainfall intensity with their frequencies and with their durations like that. What is the application in the climate science of these analyzing the let us say frequency and magnitude? As we have previously discussed, and also here we can analyze the flood, we can analyze the heat waves, drought, storm and wind speed. For flood, we can apply the GEV distribution, then return period analysis, and then can give us some sort of infrastructure design. In heat waves, we can talk about annual maximum temperature, we can apply the threshold exceedance analysis, and then that can give us the public health strategies or all that. Drought analysis can be done by using exponential or gamma distribution, or can be done by extreme value distribution as well. And we can also apply some sort of drought analysis matrix that is called, let us say, SPI, standardized precipitation index, or SPEI, that is called a standardized precipitation evaporation index. Using these types of indexes, we can also apply and calculate what is their frequencies, what is their magnitude of occurrences, and then we can suggest what is their agricultural policies across the world like that. Similarly, we can use for storm and wind analysis the GEV and GPD models, and then we can talk about their intensity, frequency trends, and based on that we can prepare disaster response planning across different parts of the world. So, this is the map which tells about the global extreme event hotspots across different parts of the world. Here, if you look at different region across different parts of the world, that what is the frequencies of, let us say, different types of extreme events, heat waves, rain and flooding, drought event, storm event, like that. So, you can look at this is giving us some sort of frequency of occurrence of these extreme events, and we can also quantify magnitude of occurrences of these events. So, once we have quantified the frequency and magnitude or intensity of these different extreme events across different parts of the world, we can plan it for different types of policies, or we can compare, let us say, which of the region are hotspot for extreme events or climate change impacts or human induced impacts like that. So, we can use these types of analysis, Python or R programming or ArcGIS. There are several libraries listed here. For Python you can use NumPy, Pandas, SciPy, Matplotlib. In R programming we can use ggplot, Extremes libraries, or in ArcGIS spatial analysis data. So, the Python and R we can use more advanced time series analysis, frequency analysis, plotting of those data set, or let us say a threshold analysis or fitting of different distributions, or maybe you can also do some sort of goodness of fit using these different libraries. In ArcGIS, once you have generated the results from Python and R, you can use ArcGIS programming or the software. You can use that software and then you can plot the results which you have obtained from your Python or R. Suppose you have done that analysis for 50 or 100 points across a particular river basin or a region, then you can plot it in ArcGIS and then you can look at what is the geospatial or the spatial correlation or regional variability across different parts. So, this analysis can also be done in Python also or R also, where we need a very specific type of libraries for plotting the spatial data set. So, there are some challenges and limitations about this analysis. For example, data quality, that is one of the most important challenge where we are looking at the missing values and measurement bias, and then we have to apply some sort of solutions. Then there is the uncertainties, we quantify uncertainties, EVT model and different probability distribution model, so that we can minimize that uncertainty and we can have a very precise results. Non-stationarity, which is very important in the time series data set, because anthropogenic factor and climate change can pose your extreme values or extreme analysis in non-stationary behavior. So, we have to incorporate time dependent variable or parameters. Also maybe you can use some sort of detrending method. Threshold selection is also very important. So, we can use some sort of mean residual life plot to optimally select what would be the threshold of certain distributions like that. Sometimes it is also possible that small sample size can give us not accurate results. Therefore, it is also some sort of challenge when we are using small sample size. Then we have to adopt different methodologies, for example, p-core threshold like that. Spatial variability is also one of the challenge, where we have a high resolution data set or perform regional some sort of data discrepancies between two different regions like that. Then is another important issue is compound extremes, compound events. For example, we are talking about only one type of extremes. It is possible that 2 or 3 types of extremes are also interfering the extreme climatic behaviors. So, we have to also talk about not only the single variable extreme event analysis. However, you can use the multiple or multivariate probability, joint probability as understanding, so that we can understand 2 or 3 different properties which are occurring together and can amplify the effect of certain extreme events in a certain regions like that. So, in the summary, we have talked about what is exactly frequency and intensities and how these 2 different matrices are crucial. We have also talked about statistical tools and different metrics which are provide insight into the past and future impacts, how we can quantify them, and that can be used for gives an more understanding about extreme events. And we have also talked about different types of challenges, limitations, data quality like that. That can be very useful to understand extreme value analysis, and we have also talked about how we can use this extreme value analysis, let us say frequency or magnitude analysis, for research policy and disaster management in terms of different extreme events. In the next lecture, we will talk about time series analysis, trends, seasonality stationarity and correlation. So, thank you so much for the attention.